Hi, you're watching Analog Output. I'm Rich Holmes, and today I am building a Eurorack module. I decided to start with an envelope generator, partly on the grounds that it's nice to have multiple envelope generators. You can have one envelope driving the amplitude, what's the word there? Amplifier, voltage control amplifier, and the other you can have a different amplitude modulation on the or cutoff modulation on the filter, or um, frequency modulation on the VCO or something with a separate envelope generator. It's also nice to have an envelope generator which, unlike the Mother-32, has um, the attack and decay and sustain level and release time, all separately controllable. In the Mother-32, you've got an attack and you've got a decay, and you can switch whether you have sustain at full amplitude or no sustain, but you have no control over sustain amplitude, and you don't have a possibility to have a decay to this sustain amplitude and then release at the end. So ADSR envelope generator, good thing to have. I considered a couple of them. There was one from Erica Synths. There was one from AI Synthesis. And both of them actually have the interesting property that they are looping envelope generators, which is to say, if you put the switch in the looping position, they don't give you one envelope, they give you an infinite series of envelopes. We'll see that later. Is that a useful feature? Well, I don't know. Might be, might not. We'll see. But interesting anyway. I decided to go with the AI synthesis one, mainly because, I haven't done any electronics aside from the ribbon controller interface in several years. Wanted to start with something relatively straightforward. This is why I'm not doing a voltage controlled oscillator first thing. The Erica Synths envelope generator looked like the circuit might be a little bit more challenging, and it also looked as though the AI synthesis build was better documented. AI synthesis, they seem to have this emphasis on do-it-yourself synthesizer building, and particularly aiming themselves toward being able to be built by novices. So they recommend, for instance, if you've never built one of these things before, start with this, which is the passive multiple, which is basically just 8 jacks soldered to a circuit board. So this is not that simple, but they do give you very clear, detailed build instructions, and there's a full real-time build video on YouTube and things like that. So, even though I'm not a novice with a soldering iron, I'm a little rusty, and so is the soldering iron. And so I figured perhaps that might be a point in the favor of the AI synthesis. So that's what I went with. So let's look at the build. Here's the AI synthesis looping ADSR kit. The panel. Maybe you saw this panel before. I was using it for checking the spacing when I was building the rack. There's a PC board, which will actually become 2 PC boards. It snaps in half. Let's see, this is a potentiometer. Got some red knobs. Got a switch with a red cap. 2 3mm mounting screws. Actually these are from the power supply. Yeah, there's a push button switch Here's a pin header. Mounting and PCB hardware. 2 more potentiometers. 3 3.5mm jacks. A card. Another potentiometer. Another. Is this a card or is this a sticker? Well, something. Resistors, diodes, stuff like that. This is headers. This is a transistor. This is one red LED with a spacer. Some capacitors. Two ICs with 2 IC sockets. And that's what's in the bag. And not in the bag are instructions. And it says, for build instructions, see, blah, blah, blah. Okay, got my instructions up on the monitor over there. And it says, first thing to do is take the PC board, snap it in half. Hopefully it snaps in the right place. And it does. So we have this board, which is mainly the components that the knobs and jacks and things that connect to the front panel. And then this is the main circuit PC board. All right, what's next? So we're going to start low to high. We're going to start with resistors. Now, I'm going to try doing something that I learned from Synth DIY guys' build videos, where instead of putting in a few resistors, turning it over, soldering it, putting in a few more resistors, turning it over, soldering it, putting in a few more resistors, turning it over, soldering, he puts in all of the resistors and diodes right at the outset. And then, of course, there's a miserable forest of leads on the other side, which would be really hard to solder around, but he doesn't do that. He solders from the top and then clips off the lead and touches up the soldering on the other side, thereby avoiding a lot of flipping back and forth and back and forth and back and forth, which makes some kind of sense to me. So I'm going to try doing that. Okay, so 10 ohm resistors. That's these guys here. Alright, that's all of the resistors and diodes, and I have double checked to make sure all of the diodes are oriented correctly. And it's time to solder them. I do have a helping hands, which I ought to be using, except that I got it out and it was so ill-behaved that I just tossed it back again. I don't know if it's just a really bad example of yard, or maybe all helping hands are equally as bad. I don't know, but I didn't find it very helpful. So I'm just going to start at this end. I'm just going to do it this way. Okay, resistors and diodes on the top board. This business of soldering from the top is going to need a little practice. A number of joints there that I needed to rework from the bottom, but it should be fine. Alright, see if I can do better on this board. Okay, I actually had to do more touch-up on this board relative to the number of components, but I'm alive. So, next is the IC sockets. And the sockets themselves are not polarized, but the ICs, of course, are, and the sockets have a little notch. So, make that little notch line up where it should. Yeah. Here's where I think some silly putty will work. Okay, that's the sockets. Okay, next the headers. There's the headers. The headers are here. I think we're good. What's next? 3 10 microfarad capacitors, which are the polarized ones. Electrolytic. All right. It says on the panel side, just the panel sides here. On the panel side, the 10 microfarad cap should be bent 90 degrees as shown before soldering it in. And 6 0.1 microfarad capacitors. Next, transistor. All right, that's the bottom board. Now, I'm going to do it a little bit differently than he says in that I'm going to place all of the panel components before soldering any of them. Red cap on the switch. All right, I want to check for shorts before I do anything else. I'm going to put these together and put it on voltage without the no, there should be one more thing. There's one more thing. There's one more thing. All right. So I'm going to connect this to there, and the red's on the positive. No, the red's on the negative 12 side. All right. And hopefully the red stripe is minus 12. We'll see. Yep, that's minus 12. All right. Turn that off. Plug this into here. Red stripe, red stripe. Okay. See if anything starts smoking. Duly warm. This thing's going duly warm. So now, put the ICs in. Hey! LED is blinking. That means it's looping. That means it's kind of working. No, it's not obviously responding to the decay knob. It is responding to the attack knob. No, I don't see any response to decay. So something may not be right. Okay, it didn't take long to find the problem. I pulled it apart and there was a solder bridge between two terminals on the decay pot. So just had to clean that up, and now maybe you can see with the decay and attack knobs turned up, the LED comes on. So can you see that here? Pull this in. Okay, now I just have to get it in view and focused. Yes, and you can see the LED slowly comes up and slowly goes away. I turn the attack knob down, it comes on fast and dies away. And if I turn the decay knob up or down, it goes blink, 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 blink very fast. So it's clearly working in the looping mode. The ADSR mode has to be tested differently, but well, the problem with the decay I found immediately when I took a look at the terminals on the decay pot. There were two of them were bridged together. Fixed that, no problem. Then I tested and I found the attack and decay and sustain seemed to be working, but the release was not, and that seemed to be shorted across the potentiometer. I couldn't see a short. I couldn't see it anywhere. And I went poking at it with a soldering iron, trying to take away solder, even though I didn't see any place where it was bridging. And then at some point, it started measuring not shorted anymore. So I don't know what the problem was. I never could see it. But what you're hearing here is we're patched into the, let me turn that up, patched into the frequency on the oscillator with this envelope generator. And we've got a gate going in, and we've got the envelope going out to the oscillator modulation. Got these set at moderate levels. And so if I press a button, there's the attack, there's the decay, and now it's sustaining. And when I let it go, there's the release. So attack, decay, sustain, and release. They're all working. If I shorten the attack and shorten the decay, if I increase the sustain, if I decrease the release, okay, so it is working. It's time to put the panel on and get this thing in its final form. There it is, behind its panel and mount it on the Eurorack. And the bad news is that the looping function sometimes sort of at random seems to stop working. Let's see, I got this set up with the VCA getting its envelope from the Moog envelope generator, and then the looping ADSR is going into the filter cutoff. And if I hold down a key, and we're in looping mode with the gate plugged in, so you can see this light isn't doing anything until I hold down a key, and then it does its thing. Mostly. There. Okay. Well, okay, it's back. I mean, I turned the knob and it stopped looping, but now it's looping again. Now, of course, you could get an effect quite like this by using the LFO with the filter cutoff. The thing is, though, the LFO is free running. This, when it's gated, is synchronized with the key, so it's always at the start of the waveform when you press the key, whereas the LFO might be somewhere in the middle of the waveform when you press the key. So that's kind of nice. And it seems to be behaving very nicely for the camera, but as I said, there seem to be times when it just sort of, the looping function sort of hangs up. That's about as fast as it loops. And as slow as it loops is I mean, crazy slow. If I turn the attack all the way up, that's the attack. Did you time that? It's like, I don't know, 12 seconds or something like that attack. Take at least 20 seconds on the decay there. So if you like the long envelopes, there you go. Okay, if I put it into envelope mode, now what happens? I'm going to turn the sustain up to about the middle here, leave the release there. So then when I hit a key, you get our attack. And decay, let's see. Let's turn the sustain down a little bit. I'm going to slow down the attack and decay a little bit. Actually, this is easiest to hear. Let me put this into the VCO frequency. And then we'll turn up so we can hear it. Set the frequency there. Okay, now you can hear when I hit it, it goes. That's the attack, that's the decay. Sustains at that pitch, and then it releases down to that. And if I turn off the envelope on the VCA, you can hear it decay down to the bass pitch. If I unplug the gate and just hit manual, you get the attack and decay. This is the same thing as putting in a trigger here, I think. Okay, it'd be nice if this actually emulated a gate rather than the trigger, but there you go. Anyway. Anyway, party tricks, but there you go. It's doing its correct thing, including looping when I want it to, even when I want to show you how it sometimes doesn't loop. Oh, here it's... Okay. Yeah, so looping the frequency thing that's fine. Anyway. Mostly working, if maybe not 100% of the time, but it seems to be working for the camera, so what can you do? Okay, it's built, it's working mostly, and we're on our way. Hope you enjoy watching this. Hit the like button if you've enjoyed this. Hit the subscribe button if you want to see the next build, which should be coming up pretty soon. And see you next time on Analog Output.